Hi everyone, thanks for coming. My name is Cornel. I run a 3D visualization and VR development studio in Singapore, and I want to talk about graphics optimization for standalone VR, especially the Oculus Quest. And so basically what I want to cover in this talk is first of all some general observations about the industry, and then some specific problems on graphics for standalone VR. Some very specific problems dealing with fading, and then I also want to touch on how VR has changed my own workflow in producing assets. And the stuff I'm talking about is I created a web page under my web URL, and I have some examples of the stuff I'm talking about there, some screen captures because it would take too long to show that here, and there's also some links about the talk, some of the topics I'm covering, and you can check it out, studiocgartist.com, Animago 2019. So I've recently published a book with A-Press, New York, and A-Press is a division of the academic publisher Springer Nature. And in this book, I basically cover techniques to produce apps using the Unreal Engine. And in this book, I cover all the important things to get you going with Unreal on standalone VR. And this is basically, I cover the whole thing, like starting with the ecosystem, history, trends, and outlook. Then I talk about the tool set, graphics, animation pipeline. I also talk about photogrammetry techniques, graphic optimization techniques. And then there's a chapter on setup where I talk about setting up the Android environment and starting with teleportation, locomotion, and the different options that you have with teleportation and locomotion. And then there are two complete project tutorials. One is a interactive product presentation, and the other one is a little puzzle game. And so the book is 324 pages. So it's this book here. There's all color. It's currently on sale on Amazon, by the way. And so it has been doing quite well. So I get a lot of mails. Even it's quite interesting from all over the place, from South America, from the Middle East. And it's kind of interesting what kind of people are getting into VR. And it's has been really an interesting experience for me so far. And as I said, like everything is done with Unreal blueprints, so no coding, no C++. It's all blueprint based. Are you guys familiar with blueprints? Yeah. Okay. So in general, I want to talk for a moment about where I think VR stands at the moment. And I think 2019 is a super important year for VR. First of all, of course, we had the Oculus Quest, the release of the Oculus Quest, which was a major milestone. And a lot of people, including me, have been waiting for that. But there's also two other very important things that happened. First of all, was the 1.0 release of the open standard OpenXR. And then it was the final release of Vulkan for supported by Unreal and Oculus. And that's also something I've personally been waiting for. A lot of people have been waiting for that. And just a quick note about OpenXR. OpenXR is helping to solve the VR AR fragmentation problem, which means if you want to develop something on Unreal and you want to address different platforms, OpenXR helps you to unify that with two different layers: the application interface layer and the device integration layer. So that means basically if you use a OpenXR plugin for Unreal, you're able to, for example, do a project that you do for Windows, and it will also run on on web VR, for example. And that's something that I'm personally very excited about, because so far the whole VR and AR field has been very fragmented, and it has been really a big headache, and this is becoming a lot easier now. And it's also going to be super important for the interface between VR and AR, where where these two different technologies meet, and this is going to be super important for the future. And then a few words about the general perception of where VR is at the moment. If we look at Google Trends, searching for Oculus Quest and virtual reality as keywords, you can see over the last 5 years, obviously Oculus Quest wasn't even around because it was only named very late, but we see there was a big hype in 2016, and after 2016 it was, it came down a little bit, but it was pretty consistent after that, and it has been pretty consistent, and it's definitely still a niche. It's not mainstream yet, but behind the scenes there's a lot of stuff going on, and I think at the moment it's a time of innovation, and the energy that's basically driving the global VR community is basically innovation, hardware, software, UX, UI, content formats, business models. People experiment a lot with that. Experimentation with haptics, increased comforts, testing limits. I mean, this is also not only done by developers, it's also done by consumers and enthusiasts. People try different things with comfort. It's really interesting to see how much experimentation is going on. And of course, it's a passion by pioneering devs, enthusiasts, and that's all also driven by community events, meetups. So it's a really interesting time, while still being in a niche, of course. And here a few quotes are picked up. Recently, there was Sushai Yoshida from Sony Studios who said, the human brain is getting used to VR. He said that in September 2019. And I think he has a really good point, because like in the early days of the latest wave of VR, up to 2016, there was a big hoo-ha about motion sickness, and people were concerned about all these things. And at this point, we, in general, as a society, we're getting used to what VR means, what it feels like, and we're getting over the novelty factor of it. So we're adapting as a society to the concept of VR. And there's two other quotes from the XR Industry Insight Report 2019-2020, which is published by VR Intelligence, that you can actually download that for free. In that Insight Report, the other quote was, product design, prototyping, most common usages for enterprise VR, which I can confirm. Like most of my job I do are basically design review apps, this kind of thing. So prototyping, product design is the typical stuff people do in enterprise VR. The other quote is, over 94% think it will take at least 2 years to impact consumers, talking about VR. And that's also in line with my own gut feeling that it's gonna be roughly about 2 more years until we see more traction with consumers. And in about 2 years, we'll probably see some signs of the next generation of VR hardware, and about that time we'll get more consumer traction, I believe. But 2 years seems like a long time. But then again, 2 years will be gone in a blip, and so that's why it's actually now is a good time to get into it, to really experiment with what's possible, what can be done with VR. As I mentioned before, referring to the quote from Sony Studios, that as a society we're getting used to VR. People very often say, like, having VR lags, meaning that you have adapted to VR. The motion sickness is not an issue anymore. And in my book, I actually talk about that briefly. That there was a big railway motion sickness hysteria in the 19th century when trains were new, and people were paranoid that trains would cause illness, and people would go crazy and nuts. And basically, it's like kind of like hysteria if you have a new technology and society adapts to that. We're finally getting over that point. So of course, when we talk about motion sickness, it's basically important to avoid discomfort, nausea, and motion sickness. Is the minimum required is obviously that you have to meet the Oculus performance targets for Android HMDs, which are 60 frames per second for Oculus Go and 72 frames per second for Oculus Quest, 150 to 100 draw calls per frame, 50,000 to 100,000 triangles per frame. And the actual geometry I don't think is so much of an issue, but more of an issue are actually the draw calls, because if you think about it, let's say you have a 3D asset that has like 5 materials on it, 5 PBR materials. Each PBR material has 4 texture channels, color, normal, roughness, metalness, and then you have 4 times 5 is already 20 draw calls, because each texture is 1 draw call. So that out of a budget from 150 to 100 draw calls, that's already quite a lot for just one asset, So that's why we have to keep an eye on draw calls, on texture usage. And that's why optimization, or basically keeping your scene optimized, is the most important thing basically for Android-based VR applications. So in my book, actually, I talk about the building blocks, and I basically separate the building blocks into like locomotion, how you move from one place to the other. If it is smooth locomotion, if it's teleportation, what style of teleportation, interaction, how do you interact with objects, then asset production, what's your asset pipeline, how do you bring your assets into the game, and then the most important thing is basically optimization, like how do you optimize your content so it runs, that you have the best case for an Android environment. And when I talk about optimization, I'm taking the perspective of not a graphics optimization engineer, because as a graphics optimization engineer, you basically take a very systematic approach. It's a job description. If you're a graphics optimization engineer, you do only that. But most of us are probably CG generalists, or I can also call it VR ninja. As a VR ninja or CG generalist, we try to avoid areas that are problematic. We sneak around them, and we attack where it's worth it, right? So basically, if we know there's a troubled area, we just like sneak around it. So that's basically a different approach, because who wants to be a performance optimization engineer? That's not the job we want. We want to focus on storytelling, on creating awesome environments. That's what we want to do. And so that's where Vulkan comes in, because Vulkan, gives us this promise of having making things easier, making graphics on a standalone headset, Android-based headsets, easier to optimize. And that means with Vulkan enabled, we get typically 20 up to sometimes 40% performance increases. And the other thing that's very important is that HDR features get enabled. And I think HDR features is really important because there's a lot of dependencies on HDR, and that's one topic I want to briefly talk about. And but that's one of the benefits we get with Vulkan on mobile headsets. And a few words about Vulkan. Vulkan is the successor of the low-level graphics API, successor of OpenGL, and it was introduced in 2015, and then 2016 it was demoed on a Samsung S7, And I remember that day when that came out, because at that time I was developing for the Gear VR. I was doing stuff on the Gear VR, and I was like super excited when I saw it. There was a demo in 2016 on Samsung S7, and I was actually using an S7 at that time. And I was like, wow, this is awesome, and you know, I can't wait. I thought maybe it's going to take like 6 months or something, but it never came. You know, so it was taking up until 2019 to finally be fully supported. Previously, there was an experimental version that was there, but finally in 2019 we have the full support. And here a few notes about what's different between OpenGL and Vulkan. I mean, in a nutshell, it's OpenGL. It's all about the drivers, you know, optimizing the drivers, and also OpenGL is a 30-year-old syntax compared to Vulkan, which is just a much more modern system. It's consistent across platforms, very optimized for mobile. So Vulkan is it's a very exciting new technology, and. But if we look at the current version of Unreal 4.23, we notice that only Oculus VR 1.36 is activated, is included in the official version, and that's actually the version that doesn't support Vulkan. So to be able to get the Vulkan version, we have to pull it from GitHub, from the Oculus branch. So basically to do that, you have to sync your Epic Games account with your GitHub account, and then you can pull the Oculus branch, and then it's actually what you need is the 1.39 Oculus VR plugin, and you can pull that branch. But I actually, it's expected to be in the official version soon, probably in the next release, 4.24. They always lag behind a few versions, and then in the official version, it should be in the next release by Unreal. And so what's important that in the final version of Vulkan, we have now multi-sampling, anti-aliasing, which wasn't included in the experimental version before. We have Multiview, which is super important for performance. A fixed Foveated rendering, which is also important. But then, you know, the mobile HDR features, which I'm very excited about, which previously you could not use mobile HDR because it was a total performance killer. And with Vulkan, it becomes possible to use mobile HDR. And that means, you know, full HDR lighting. Then the HDR pipeline with some post-processing features. Think tone mapping, grading, and translucent is blended in linear space. That's very important if you want to do layering. And realistic specular reflections on surfaces with support for variance and roughness. So that's very important for eye candy. You know, something you see in high-end apps like Red Matter, where they actually did not use Vulkan. That was done in Unreal 4.19, but they use their own shaders. But that kind of eye candy we will get with realistic specular reflection on surfaces with support for varying roughness. But the example I want to talk about real quick is the importance of fade out and fade in for teleportation, and how that relates to HDR. Because what I usually do with my business, I do mostly B2B apps. So these are usually, trade show presentations for an audience that's not used to VR. These are not hardcore users. These are not gamers. So everything has to be super comfortable. And so the fading is really important. That when people fade from one position to another position, you need to fade out, and then in the new position fade in. And previously that was not easy to do, because previously there was the non-HDR workaround that workaround I cover in my book. And that workaround is where I use UMG widgets to do that. But now with Vulkan we have HDR-enabled tools, so we can actually use the techniques that people use on PC. If you do fading on PC, it's on Windows, it's easy to do. You just use the sequencer, do a fade track. And there's also there's a new option provided by Oculus, which I don't think a lot of people know about. So I want to also mention that because there's a new node that in the Oculus library that allows for easy fading on standalone headsets. So as I say, fade out, fade in is essential in VR to comfortably transition between immersive worlds. So, and for fading is basically, it's also a storytelling tool, because if you have an immersive world and just think about presenting the user with an environment, and if you fade between different environments and have, for example, a voiceover, that could be that is already telling a story. So it's basically, fading is super important for comfort and also for storytelling. It's one of the basic components for a good VR project, and that's why it's super important. So in my book, I do this workaround, and basically here I use the UMG widget. So basically what I do is I just add add a track to the canvas here and do an animation on the opacity. And in the event graph, I do an event construct, put the animation in there, a delay for as long as the animation runs, and then remove it from the parent. And here on the level blueprint, I just call up the UMG, do again the same delay, and then add it to the viewport. So that means basically the UMG is mapped to the full viewport. But that is not really, this is like a workaround, because this is the only way it works on mobile headsets and mobile and standalone headsets, on Android-based headsets. But this is a method that works, but it involves quite a number of steps until you get there. Then if you have HDR, so basically on PC, on the traditional method, it's super easy. You just take your sequencer, add a fade track, and bam, you're done. That's all you need to do. Or, of course, for example, if you look at the VR template, it just uses a camera fade node, and that's of course equally easy. But both of these require HDR. So without HDR, those won't run. That's why on mobile, on Android, we need this workaround. But then there's a new option provided by Oculus, and that came out like late 2018. And it's part of the Oculus library. And I think hardly anyone knows about it. And one of the reasons why people don't know about it is because the description is actually wrong in the documentation. It says enables orientation tracking on devices that support it. It's obviously completely wrong, and because it's basically color offset and color scale and offset. But this is a super nice and easy and inexpensive way to do fading, and it works beautifully on Android headsets, on the Android-based VR. But one thing I should note is that it only color scaling works. Color scale works. Color offset doesn't work on Android-based VR. So here's an example. I just took a simple event overlap, and then 2 linear colors and lerp between them, and then I'm feeding that into the set color scale and offset node from Oculus, and that's it. That's all you need. And that basically what it does, it affects all rendered pixels, and it's super inexpensive. It's easy to set up. It makes things so much easier, And so on the link I put in the beginning, you can see I have the examples on my webpage. You can check it out. So this is another example where I took the setup that's in the VR template, and to make it more obvious, I added the blueprint interface interaction. and had a color change on the cube that I'm grabbing. I'm grabbing a cube, and then at the moment I grab the cube, the fading sets in, and at the moment I release the cube, it reverses the fading, so to make it more obvious, and it's also on the web link. So a quick note when we talk about the VR template. So on the Quest, it's super easy actually to use the VR template to have a quick start doing stuff with Unreal on the Oculus Quest. And basically you can just, if you use in my book, the chapter setting up a basic Android project, if you use the same techniques that I have in my book, it's super easy to set up. In the book, I don't use templates at all because I think it's important to know how to build things from scratch. And but sometimes it's good to have a template to quickly want to put something together. And the good thing is the VR template works on the Quest. You instantly have two hands that are interactive that can grab things. And I very often change the input settings because for example, the grab action I put on the grip button because it's more consistent. It's like a VR convention that you do the grab on the grip button, and I put the teleportation on the trigger because it's also very user friendly this way. And then the cool thing about Unreal, I usually tell that Unity users because I think in Unity it takes so much longer to set things up, and it's so quick and easy to use Unreal if you want to have a quick start. For example, if you use the VR template, all you need to do is to make assets interactive. Here, for example, I took the Suzanne head from Blender, just imported it as an FBX, and then converted the FBX to a blueprint. Then I added the blueprint interface under interfaces, and then copy and pasted the blueprints from some of the interactive cubes in there, and then immediately the imported FBX, which is the Suzanne head from Blender, becomes interactive. You can grab it, you can throw it, the physics are enabled. So basically you can create an interactive scene with imported assets in no time, just within a few minutes. So it's super quick and easy using the VR template. If you know what you're doing, if you understand how blueprint interfaces work, it's a super fast way of building a playground with imported assets. So that's the power of Unreal, I think, to really make it easy to get going. And one thing I want to point out is basically in my book, most of the tutorial projects in my book are based on selection ray interaction, which means you use a laser pointer to grab things and to interact with objects. While, for example, in the VR template, you're using 6-DoF spatial interactions. Basically, you have to reach out to grab an item, basically with overlap. And I use selection ray interaction because it's basically one of the standards of VR, how to interact with things. Spatial selection ray interaction, even 6-DoF headsets use selection ray interaction very often for menus. So it's one of the standards how you interact with content, and that's why my tutorial projects are all based on selection ray interaction, because to have it more consistent between 3-DoF and 6-DoF projects. But in the end, what that means is they're actually not that different to set up. So basically, if you want to change a project that has selection ray interaction, you want to change it to a 6-DoF spatial interaction, all you need to do is basically do, instead of the line trace hit result, where you store the result in a variable, and create the interaction with the blueprint interface. And so basically, this is what this is what I use in my book. All you need to do to change that to 6-DoF is you use an overlap hit result to replace the line trace hit result, store the hit object in a variable, and then do the same thing, interact with the blueprint actor using a blueprint interface. So it's basically not that different, so it's pretty similar. as I said in my book, I use selection ray interaction for everything to have it consistent. So you basically, all the examples work on the Oculus Go or the Oculus Quest. So the two tutorial projects in the book are, as I said, one is an interactive product presentation where we have a floating menu where you can activate items on the exhibit object here, which is supposed to be a warehouse with a jet ski prototype. You can lift the hood, and you can change the colors. And so this project is built from scratch, blocking it out in Unreal, then taking it into a Blender, refining it, creating the textures in Substance Designer, and then setting it all up to make it interactive, and then run it on the Oculus Go, for example, on this one. And that is all done with selection ray interaction. And on the other project, which is a little puzzle game, which is based on a fixed slot inventory system. And this little puzzle game, also all the interactions are done with selection ray interaction. So in this little project, what it is basically we have two rooms. In the first room, we have to find two keys. One key is in a chest of drawers. You have to open the drawers, find the first key, put it in your inventory system. Then the second key is under a pile of boxes. You have to remove the boxes, find the key, and put it in your inventory system. Then you need the two keys to unlock the sliding door. And then you can enter the second room. In the second room, there is a hostile guard that's attacking you. And to be able to survive the guard, you have to pick up these health items, and you have to kind of survive the guard attack and then make it to the final exit. And there's a door that you have to equip a bomb, and that bomb then blows off the door, and then you can escape to the second door. So this is the second tutorial project in the book, and all the interaction is done with selection ray interaction. And both of these projects work either on 6DoF as 3DoF, so either Oculus Go or Oculus Quest. And another note, with blueprints can easily get out of hand. There's a funny blog. It's called Blueprints from Hell on Tumblr. And you should have a look at it. It's really funny. There's like these crazy blueprints. I mean, sometimes they turn into pieces of art. It's like absolutely mind-blowing what people do. And at that point, it's not fun anymore. At that point, it's not fun anymore. And so that's a thing. I think, especially that's why I try to keep blueprints as simple as possible. And I mean, of course, for the book, this kind of stuff obviously wouldn't work for the book. So I try to keep things very clean and simple. And the projects in the book are, of course, done in very simple setups. So otherwise you wouldn't be able to read it in the book, obviously, right? So it's. So I wanted to quickly touch on PBR workflow for VR. As I mentioned in the beginning, performance overhead. Each texture is a draw call, which I think is a big deal if you want to have like really rich looking assets. Then, restrictive normal map use. I mean, there used to be a big discussion about normal maps in VR. In the beginning, people were saying you don't use normal maps because normal maps don't look good in VR, but these days everyone uses normal maps because objects just look better with normal maps. But we have to keep in mind that normal maps are not stereoscopic. So normal maps will never look 3D, but most of the time normal maps are really not used in a way to make things look 3D. It's more the light interaction that makes normal maps important in environments and stuff. And that's why I think normal maps are fine, but you have to keep an eye on the distance and the angle you're looking at it. If you have like a normal maps right in front of you, then it wouldn't look good. So you always have to make sure when you use normal maps at a medium distance and you don't have an angled view on them, because then it's just not gonna look right. So normal maps are sensitive in VR, and we have to keep an eye on it that they're used in the right way. And it's always good to study how other people use normal maps in VR. A checklist, what to watch out. The checklist in my book is much longer. Here's just some of the highlights. have meshes and materials merged, bake PBR textures just down to a color map, use modular meshes, use LODs obviously, set all lights to static, make sure the texture sizes are optimized, multi-view has to be enabled. I sometimes forget that. And then sometimes it's good to have distant environment meshes baked to a skybox. I've done that successfully. So these are some of the highlights of a checklist. There's a longer list in my book. And as I said earlier, it's always good to study apps that are pushing the limits on, and I think the games at the moment that are pushing the limits are Red Matter on the Oculus Quest and Daedalus on the Oculus Go. I mean, they're both beautiful games, and it's really, I think it's really good to study how they use textures and environments. I think Red Matter is really interesting. It was done with Unreal 4.19, and as I said, they use their own shaders. They programmed their own shaders with it. But with Vulkan, we should be getting close to what Red Matter was able to accomplish. And Daedalus is also a beautiful use of textures. In Red Matter, they also use a lot of dynamic lights, which is also unusual because a lot of people try to avoid dynamic lights for the performance hit. But I think it's important to look at what other people do that are pushing the limits to see how far you can go. And another thing that I sometimes do is test your optimization skills with content that's not meant for mobile. You know, for example, there's on Unreal, in the Unreal Marketplace, there is a free content that's free to download on the marketplace, the subway scene, and that's a scene that's not meant for mobile. It's for PC. It's super detailed, has a lot of texture details, dirt, dust, scratches, a lot of scene complexity, heavy PBR texture use. So it's not at all meant for mobile. So if you use that scene and you try to optimize it, so this is basically going to the gym and working out, trying to work on your optimization skills to make that run on the Oculus Quest. So basically I took, for example, this scene, started to optimize it. In the beginning I had initially 30 to 40 frames per second, which is obviously way too low. But you know, I mean, this is not good enough, but it's a good starting point. You know, it's not that it doesn't run at all. So that's a good starting point, because with 30 to 40 frames per second, you know you can go places. I mean, if you heavily optimize it, then you will finally make it. And especially if you have Vulkan, then you get an extra 20% at least. And then very often I do I do the console commands. I put them on my controller on the face button on pressed. I put a chain here of the console commands, stat FPS or stat game, and so forth, etc. And on release, I switch to stat non, which makes it disappear. So that's an easy way to test your content. So basically, I used the free marketplace content and just made it VR ready using the standard techniques, add a VR pawn, add the basic VR controls, and then try to optimize that content. So, and what I briefly wanted to touch on is also, like, I mean, since I've been working with VR, in the beginning I totally ignored the asset production tools. But recently I've been getting into using Gravity Sketch, and I have to say it's really amazing. You know, it's really changed my way of working. I didn't take it seriously in the beginning, but now I'm really into it, and it gives you a completely new perspective, especially on the Oculus Quest, because you can sit somewhere else. You don't have to use at your workstation. You can sit on your sofa, and it gives you kind of like a different point of view. It's like you feel different if you sit somewhere else, and then you can basically do concept modeling, ideation using Gravity Sketch. Take that. Then if you have something that you think you like finish it, retopo it, do the texturing on desktop, and then later re-import it and finish it to present in Unreal for VR. Here's I wanted to create an evil-looking alien spaceship, so that I basically sketched out in Gravity Sketch, then later textured and then re-imported. So I think that's also something working in VR. That's one of the benefits of kind of like learning new ways of doing things, and that for me was a total eye opener to kind of like opening up to Gravity Sketch as an asset production tool, which I never considered before. Then the next testing ground is for me. So when I got into VR, one of my bigger projects in the beginning was doing a VR app for The Future is Wild, which is a TV show that was on Discovery Channel. It's about like what animals would look like in 200 million years after mankind is already finished. And so basically I did a lot of concepts or prototypes for them. And since then, I've been involved with that scene. It's called the speculative biology scene. It's kind of like a niche, special interest where people develop creatures. And but I'm still hooked on that genre, and I still do stuff in that genre. And that app that was released in 2016, that was actually my first big project in VR, and it was presented in Cannes at the MIPCOM conference there, and that actually got me started with VR, and that triggered a lot of other projects. And The Future is Wild. At that point, I thought, wow, this is perfect for VR, because this genre, speculative zoology, is basically about creature creation, but creature creation with a bit of a scientific thinking behind it. And this genre has been around for quite a while. It was originally initiated by Dougal Dixon. He wrote that book After Man, I think it was in the 80s. And this became a cult in Japan. And recently they released their first book in China, which became a hit immediately, was immediately sold out. And so I think it's a super fascinating genre. And I use that personally a lot to experiment in terms of creature creation, in terms of like showcasing things in VR. And so that my point is that The Future is Wild is, like, as I said, is the undisputed premium brand that made the spec zoo genre, speculative zoology, accessible to a global audience, applying scientific principles and storytelling to the creature creation process. But it doesn't all have to be The Future is Wild. For example, it's a great playground for an untapped resource for CG artists. It's a flexible genre to, come up with alternative concepts and new ideas, innovative IPs. And that's why I've been sticking to that spec zoo genre. And I'm doing a new project. It's called Project Biotope, and it's so basically it's kind of like The Future is Wild, but it's a bit more. It's not as strict on science on the science part. It's a bit more loose on the science. So it was inspired by this painting. This is a painting from 1690 by the Austrian painter Rosenberg. It's called After the Fall of Man. And basically this painting inspired the whole project. And this project is about how would animal life develop if we took animal life to a different planet and without mankind. How would animals develop on a different planet? And the goal behind this project is to bring together spec zoo conceptors, which are not people that are very artistic. They're more into biological concepting, into biomechanics. They're not artists. They're more like interested in science, and bring them together with ZBrush creature artists and Unreal environment designers to kind of bring these different people together to create interesting new content and document the process and do VR creature showcases on the way. So that's stuff I'm currently working on. So I'll probably have something on my website about like 2-3 months or something. And of course, when we're talking about creatures in VR, that of course touches the animation part. And in general, of course, creature animation is basically very similar to character animation. So in my book, I cover the whole workflow of character creation, character animation, setting up from scratch a character. By the way, this is the old default character from Softimage XSI. I still use it. I'm still kind of attached to it. So it's like kind of like a nostalgic attachment. So I use that in my book to set up the character from scratch, set it up with the animation blueprints, set up the behavior tree for the AI, and so basically for the enemy character in the little puzzle game. And I'm using Aikitsu. It's an animation tool that's very popular with game animators. And basically, this, of course, also applies to creature animation, but I'm in the process of learning personally more about creature animation in Unreal, and maybe there will be another book. Maybe there's new learnings about it, so we'll find out. And that's basically it. Thank you very much. Hope this was had some interesting stuff in it. As I mentioned before, check out the webpage I had in the beginning. Here's my book. Thanks.